Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello students of Senior 1 Chemistry class. You're most welcome for today's lesson. Today we are going to study Unit 3, that is states and changes of states of matter. All right? States and changes of states of matter. That is our today's unit or today's topic. Under that we are going to look at, it is lesson 4, and we are going to look at the definition of matter and the states of matter. All right? Definition of matter and the states of matter. So what is today's objective? So every day we always talk of the objective of the lesson. What is the objective of our today's lesson? So today's objectives are, 1, everybody here, by the end of this lesson, will be able to differentiate physical change and chemical change. All right? This is under matter and the states of matter. The physical change and chemical change. All right? Everybody here will be able to describe the change in states of matter. All right? By the end of this lesson, under the unit matter and the states of matter, you will be able to describe the changes in states of matter, to differentiate physical change and chemical change. Okay? Hope everybody is ready and we start off with the lesson. Good. So what are we going to start with? We're going to start by looking at what matter is. What matter is. All right? What matter is. In the primary level, you studied about matter. And you looked at, this is not new for you. You studied matter, you looked at the states of matter, and I think everybody now can, as we pass through, we will be reminding ourselves. So what is matter? Yeah, matter, that all substances found in nature are made of matter. All substances found in nature are made of matter. Therefore, what is matter? Matter is anything that occupies space and has volume or mass. So matter occupies volume, or anything that can occupy space or can occupy volume and has weight or mass, that is matter. Right? That's why we say that in everyday life, in nature, all substances are made of matter. So what are the 3 states of matter now? Or what are the states of matter? In nature, we have 3 states of matter. Those are solids, liquids, and gases. I think this is very clear. So because I've said that all things in nature are made of matter, all right? So we find things in nature in the 3 states. Those are liquids, gases, and solids. So most of the things we have in nature, they are in form of solids, in the form of liquid, in the form of gases. So what are some of the examples of substances or substances in solid state? Who can mention? The things you have in nature or around us here that are in the form of solids, yes? Yeah, soil, chalk, salt, sugar, wood, metals, and others. All those that are in form of solids, we call them to be under the state of solids. All right? So what are some of the examples of substances that are in liquid state? The substances which are in liquid state, we can mention water. That one is obvious. Calcium, milk, spirit, anything in the form of liquid state. Or anything in a liquid form, we call it to be under a liquid state. All right? So gases. What are some of the substances we find in a gas state? We have air, biogas, oxygen, carbon dioxide. All that are the examples of substances in a gaseous state. So as I started, we said all substances in nature are made of matter. All right? So you find all the substances in nature to be in the three states: the solid state, the liquid state, and gaseous state. And we have given some of the examples of those substances. Hope that one is very clear. What is the next thing? The next thing is now to look at those three states and their properties. What are the properties of the three states of matter? Look at the solids. You know, we have given the examples of the solid state, we have given the examples of the liquid states and those in gaseous state. Now we're going to look at one by comparing their properties. Normally we look at around 4 properties. Here we focus on the shape. How is the shape of substances in the solid state? How is the shape of substance in liquid state and those in the gaseous state? We look at the rigidity. We look at the compressibility. Are they compressible or not? Are they flow? Do they flow? Those are the 4 main properties that we focus on. All right? And we compare one by one on each case. So let us look at the shape of solids. Remember the examples we have given on the solid state, all right? If you go back and look at the examples, we talked of the soil, we talked of the chalk, we talked of the salt, sugar, whatever. So how is the shape? How is the shape of these substances in solid state? The shape and volume of substance in a solid state that are fixed. So solid state have got fixed shape and fixed volume. All right? So you can tell this substance has this, when we talk of the shape, we can say it is irregular, it is irregular, it is rectangular, it is a square, it is any shape you can mention. So solid state have got a shape which is fixed. But you look at the liquid state. When you go to a liquid state, we say that they have a fixed volume. They have a fixed volume. The volume is fixed, but the shape is not. Occupies the shape of the container. Let's say when you have water in a glass, when you have water in a glass, let's say you have 100 milliliter of water. You put it in a glass, all right? And then you transfer it, let's say, in another container, in a cup. And you transfer it again, let's say, in a basin, for example. When you measure the volume of that water, the volume will remain 100. I think that one is very clear. So the volume of liquids does not change. It is fixed. But look at the shape. When you go to the shape of liquids, as I was giving the examples, you get water and power in a glass. It will take the shape of the glass. Transfer it, let's say, in a cup. It will take the shape of a cup. Power it, let's say, in a basin. It takes the shape of the container. So it does not have a fixed shape. That is the liquid. So for the liquid, they have fixed volume, but they don't have a fixed shape. They take the shape of a container. All right? Look at the gas now. Talk of the volume and the shape for the gases. The gases don't have fixed shape, nor do they have fixed volume. What does it mean? So for the case of the gas also takes the shape of a container. All right? But the difference with the liquids is that for the liquid, you don't need to cover. But for the shape of the gas, if the gas is in a container, you need to cover a container such that you maintain the shape of the gas. So let's say you want to remove that gas and power it in another container, let's say. It takes the shape of that container in which you have put it. But you need to cover for the case of the gases. You need to cover. For the liquid, no need of covering. So the gases do take the shape also of what? Of the container. All right? Even the volume. Hope that is clear. So for the case of the volume and shape on 3 sides, it's only the solids that have got fixed shape and fixed volume. It's only the liquids do have fixed volume, I said, but not fixed shape. The shape of the shape of the liquid is taken according to the shape of the container in which the liquid is powered, as I gave examples. Then the gases do not have fixed shape. All right? They also take the shape of the container, only the difference between the liquid and the gases is that for the case of the gases, you need to cover the container such that you maintain the gas in the what? In that container, and it takes the container's shape. That is one property. Another property is the liquidity, all right? That for the case of the solids, they have liquid particles which vibrate within a fixed point, all right? So you have, for the case of the solids, their particles are compact. They are closely compact. But look at the particles of liquids. Particles slide past one another. They are a bit far from one another. A bit far from one another for the case of the liquids. But for the case of the gases, particles move very fast. They are free, there is free movement in case of gases, all right? But for the case of the liquids, a bit far from one another. But for the case of the solids, they are compact. The particles are compact, all right? That is liquidity. So they only vibrate in one space, fixed position for the solids. But for the liquids, they slide on one another. But for the gases, they move. You see, where we are standing here, gas is just moving freely. But if it was a liquid, it just moves, particles slide on one another. But for the case, take an example of a wood. For the case of the solids, particles just vibrate in a fixed point. That is it. So we talk of compressible or compressibility. If you get a solid substance, take an example of a stone or a wood or whatever, a solid thing, and try to compress it, try to squeeze it. It cannot easily be compressed. Why? Because the particles are compact. But talk an example of the liquid. Do you think that the liquid are compressed? Liquids are compressed at a very small extent. When you get water in, let's say, a container, or like water in a bottle, you try to compress the bottle. The bottle, it's like the air inside that is being compressed, but not the liquid itself. So there is a small extent of compressing the liquid. But for the gas can easily be compressed. You get, let's say, a balloon. You have a balloon, then there is air in a balloon, then you try to compress a balloon. It is compressible to the extent that it can even burst, all right? So for the case of compressibility, the solids are not compressible. For the liquids, very little extent, but gases can easily be compressed, as I've given you an example of the balloon, all right? When you get a balloon and try to compress it, there is the air, there is gas, try to compress it, it can be compressed to the extent that it can even burst. So it's the air or the gas that can easily be compressed. Talk of the flow. When we talk of the flow, that is like powering it. When you power it, the liquid doesn't flow anyhow. It doesn't flow at all. If it is a stone, you throw it, it will remain there. But talk of the liquid flow easily. It flows easily. But talk of the gases flow very fast, because wherever we are standing here, in a class here, you see, gas is just flowing anyhow. Even though you don't see, because gas is colorless, but it is flowing, all right? So for the case of the solids, does not flow at all. You throw a stone in one space, you find it there. But a liquid, you pour water, it will move to a certain distance. But gas just flows, all right? So that is it. So down you look at the particles, how the particles on the screen there. When you look on the slides, look on the slide there and see. When we go on the slides, we find that the solid state, or those substances in the solid state, the particles are compact, right? When you go on the slide there. I take these ones that are in a circular form to be the particles. So when you look at these particles, they are a bit closely to one another, right? But you look at the particles in a liquid, a bit far from one another. The distance is a bit far from one another if you compare with that of the solid. Is it clear? But it rush to the gases, very far from one another. If you compare the distance of from one particle to another, it's a bit far than those of the liquids and those of the solid. For the solids, as I said, they are closely compact, all right? Closely compact. But for the liquid, a bit far from one another. So those are the three states of matter and their properties, all right? Hope everybody now has known what is a matter and what are the three states of matter as our objective, that at the end of the lesson, every learner will be able to describe the three states of matter properly. You describe them by giving their properties and trying to differentiate their properties as I've done for you here, right? So the changes of the states of matter. What are the changes of the states of matter? The states of matter, as I said, you have solid, liquid, and gas. They are able to change. One state can easily change and turn to another state. For example, the solid state can turn to a liquid state, and the liquid state can turn to a gas state. Right? So what is that process? When a solid turns to a liquid. When a solid turns to a liquid, we call it melting. Take an example of ice. All right? When you get ice and melt it, it becomes a liquid. So that phenomena or that process, we call it melting. So this arrow shows that we are changing from solid to liquid, all right? And the process is melting. So there is a situation where now a liquid can go back to a solid. That one is freezing, all right? That one is freezing. Get water, then put it in freezer, then in few hours, it will turn into a solid, that is ice. So we call that one freezing. So now a liquid can turn into a gas. Those are changes of the states of matter. A liquid can turn into a gas. Get water and boil it. Water is a liquid. When you get water and boil it, that is evaporation. Water will turn into a liquid. A gas. You will see water trying to evaporate. It will be moving in the form of a gas. We call that one evaporation. A situation where the liquid turns into a gas, or you're boiling water, and now the liquid is turning into a gas state. So we call that one evaporation. Now I need to collect the water that has evaporated. So I had my water, I was boiling it, it is turning into a gas. So I want to bring it back into a liquid. For example, you can get water and you boil it, all right? When you boil that water, it is turning, if it reaches at 100 degrees Celsius, it turns into a gas state, starts to evaporate. Now we need to collect back the water that is boiling. What do you need to do? You do what we call condensation. You have to cool it, to condense it, all right? So when you get water, evaporated water in a form of a gas, then you collect it. You can get a kind of a saucepan, you put water, you boil it. Then when you cover it, for example, when you cover the saucepan, then you will find droplets and you leave it to evaporate, then you leave that to cool down. You will find on the cover that water that had evaporated, it is trying to condense and form some water droplets. All right? So it is very easy for you to condense or to collect back the liquid which had turned into gas. So that phenomena or that process is condensation. Turning gas into a liquid, it is condensation, all right? So now there is what we call a direct change. Direct change from solid to liquid, all right? When you turn from solid direct to gas, direct change without passing into a liquid state, we call that one sublimation. So what is sublimation, class? Sublimation is the direct change from solid to gas without passing into a liquid state. That is the arrow here. This arrow that runs direct from the solid and goes to a gas state. So we call this one sublimation. So sublimation, it does not pass through the liquid. No. It passes direct from solid to gas state. All right? So there is also this turning from the gas state to the solid state. Direct from gas without passing into a liquid state, direct to solid state, we call that one deposition. All right? So those are the changes that happens when you're trying to change the states of matter from solid to liquid, from liquid to gas, and from directly from solid to gas, and from gas to solid. All right? Hope that one is very clear to everybody here. Any question? Hope it is very clear. Good. So we are looking at what we call the physical and chemical changes of matter. What are the physical changes? The physical changes, we can call them temporary changes. The physical changes, we have examples. These are changes whereby it happens just temporarily. For example, you heat a wax, you boil liquid water to steam. When wood is broken into pieces, there's no change completely. This is a temporary change. All right? For example, when you boil water, as I said, it becomes gas, but it can turn back to liquid. So that one is a temporary change, but not permanent change. You get a wood, the wood, you break it, doesn't change the state. All right? So we call that one a physical change. A physical change is the kind of change whereby substance just turns and can go back to its original state. All right? Now, what is a chemical change now? A chemical change is a permanent change. For example, you get a wood. When you get a wood and you burn it, it becomes ash. Whichever way you want to turn it back to a wood, it will not turn into a wood. Will it? It cannot. Get a wood, burn it, it is ash. It can't go back to a wood. That is a permanent change. But if it was a physical change, as I said, when you heat water, it becomes steam, then you can cool that water and goes back to liquid state. That is a physical change, just temporary change. But if you burn a wood, it will become ash and cannot go back to be a wood again. So that is a chemical change, permanent changes. Ripening of a banana. You get a banana, then you keep it for some days, it ripens. So whichever way you want, it won't go back to become the green banana. So that is a permanent change. So that is an example of a chemical change. So chemical changes are permanent changes, whereas physical changes are temporary changes. When you want this, that thing that you have changed to go back to its original, you can do it for the physical change. But for the chemical change, however much you want it to go back to its original state, it won't go back. All right? So I think physical change and chemical change, you can easily tell what, if you're given some examples, you can differentiate this is a physical change, this is a chemical change. Those which are permanent, we call them chemical changes, and those which are not permanent, we call them temporary changes. All right? Good. So what are the characteristics of a physical change? A physical change, in the case of a physical change, no new substance is formed. As I said, when you get a wood and you break it or you cut it into pieces, it doesn't change. It remains as a wood. But for the case of a chemical change, you get a wood, you burn it, it becomes ash, a new substance is formed. So for the physical change, the mass of a substance does not change. So for the mass of a substance remains for the physical change. If a substance is weighing 2 kgs, like a wood, you cut it, it is 2 kgs. I mean, it was 2 kgs. Even if you cut it, it remains 2 kilograms. All right? But for the chemical change, it is the mass changes. All right? It is irreversible. It is difficult to change the new substance back into its original state. That is irreversible for the chemical change. But for the physical change, it is reversible. it can go back to its original state. All right? Those are the physical states. I mean, those are characteristics of a chemical change and the characteristics of a physical change. So to remind you, the physical change is not permanent. It is temporary. It is temporary. You boil water, it becomes steam. When it becomes steam, you can cool down the steam, and then it goes back to a liquid state or to be water. All right? You get water, you freeze it, it becomes ice, but you can melt ice and go back to a liquid state. That is not permanent. It is temporary. It is a physical state. But chemical change, as I said, you get a banana, you ripen it, it becomes a yellow banana. You cannot take it back to a green banana, whichever way you want it. So it is permanent. It is irreversible. These are good words to use. Physical change, a reversible reaction, or reversible change, it is reversible, whereas chemical change, it is irreversible. It is permanent, in other words. All right? So hope that one is very clear to everybody. So as we had started the subject, the topic, we had said that by the end of this lesson, we shall be able to tell the definition of matter. What is matter? Anything that occupies volume and has got mass. The three states of matter: solid, liquid, and gas. So they differentiate physical change and chemical change. A physical change is not permanent, it is temporary. Chemical change is permanent. Physical change, in other words, it is reversible. Chemical change is irreversible. So you describe the change in states of matter. Where matter becomes solid, can move from solid to liquid to gas and the reverse. All right? And those properties of physical change and chemical change. Okay? Hope that the lesson has been, you have enjoyed the lesson.